In this tutorial we will go over how to rig characters with IK controllers so you can use the powerful tools in Cascadeur and use the animation inside Blender, but this can apply to any other 3D software. So in many cases you will have a character similar to this with different control objects to help you create animation inside Blender. Because different 3D software handles control rigs differently, transferring the animation to these control rigs from one software to the other can be quite challenging. Luckily, if your deformation bones have the correct hierarchy, this issue can be solved relatively easily in Cascadeur. So one of you guys sent me this dino rig, and I think it's a perfect example because it has different controllers that you would usually find in many other rigs. For example, it has a usual leg IK with a pole target, and it has a controller for curling the fingers, even different bone controllers for shape keys. So if we make every bone visible and turn off the shapes for these bones, you can see that the control bones are just regular bones and they are controlling the deformation bones. But in Cascadeur you would directly control these deformation bones. So what we want to achieve is that these control bones move together with the corresponding deformation bone. And since this scene is nicely organized, I can simply select everything that I want to export by selecting every object inside the collection. And for exporting I will use the Cascadeur bridge add-on, but obviously you can do it manually as well. The most important setting is the only deformation bones, because here you also want to export the non-deforming bones, like the control bones. And I will export only the selected objects, and also one important setting is the odd leaf bones. Usually you wouldn't want to use these settings, but I think in this case it makes it more convenient to rig the character in Cascadeur. So to compare, this is how it would look with leaf bones, so it's quite similar to what you would see in Blender, and also if you check the tail it ends exactly where I want it to end. But if I now go ahead and export without leaf bones, then you will see in a couple of seconds that obviously you have less joints, which is usually more convenient, but in this case, especially for the tail ends here, it's quite hard to select, but this bone is actually the tail controller bone, which is parented to the root. And also it's quite hard to see where the control bones are in some cases, like here. It's quite hard to know which one is the deformation bone and where is the head target, which is that tiny bone. And here you can see it quite clearly with leaf bones that this bone is the control bone for the head. So I will use this one with the leaf bones because I think it's more convenient. You can choose whatever you like. So now we will need to create the control rig inside Cascadeur, which can be a bit tricky with all these joints in our scene. So first we need to identify the deformation bones, which is quite hard to see which one are the deform bones and which are not. As you can see in the hierarchy, I have one root bone and a hip root bone, and only after that starts the spine. And I will start rigging from this spine bone. I've already made a video about rigging non-humanoid characters, so I won't get into details here, but you can check out that video from the top right corner. I will just create two rigid bodies for the neck and add a spline IK, because with the Blender rig the neck is controlled by the head. And also the tail starts with this single tail bone. I will also create one rigid body for this. For the tails I want to make sure that I have one rigid body between these controller bones, and I will also add spline IK here. For the leg and the arm I added rigid body to every major joint, and I also added rigid bodies for the middle finger on the leg, and this can be useful with floor collision, so I can go to the object properties and activate floor collision for these rigid bodies. Then I need to set up the hinge action for the leg, so I have a pole target for the knee. And I will also add rigid bodies for the upper arm, lower arm and the hand. And I set up spline IK for the tail and neck. This will ensure that I have a similar deformation as I would have in Blender. but they won't match perfectly, so keep that in mind. But now if we check the outliner, you can see there are 3 different branches for the rig elements, which is not desirable. So I will need to drag and drop the tail and the leg branches under the spine so they have the correct hierarchy. I will also add box controllers for the jaw and the tongue. I don't need rigid bodies for this because they don't significantly affect the physics, but it's nice to have controllers, so box controllers are the way to go. So keep in mind that these last joints are the leaf bones, so you don't need to rig them. You could also add box controllers for these jiggle joints that we saw in purple in Blender. I don't think it's necessary in this case, so I will just skip them. And now I need to set the size and mass of the rigid bodies, scale the point controllers, etc. Because we have a lot of clutter here, I will change the visibility and selection settings. First I will adjust the rigid bodies and the point controllers, so I will hide everything else and make them unselectable. You can adjust the size of the rigid body by typing a number here, for example 9. Or you can also click in the input field, and while keeping your mouse over the input field you can use your scroll wheel to change the size. And to set the mass of each rigid body, for reference I use the sample Dracorex model. So I pretty much use these values that you can see here. It has 40 kilos. And then I also went through the box controllers, so I turned on the visibility for them and turned off visibility and selection for everything else. And you can scale them easily with the scale manipulator in local mode. And also a quite useful tool is the copy tool. So if you set the correct scale, for example for one finger, you can go to the copier tool, and I only selected the scale, so I will only copy scale. So I can press Ctrl C with the first box controller and Ctrl V to paste it for every other controller. And when every scale and mass is properly set, then I can mirror the limb, so I don't need to do it on the other side. So set the correct mirror plane and the mirror prefix, and then just create mirror objects. This is usually the point where you would generate your rig and start animating. But if you were to do that, then I will demonstrate how it looks. So I will turn on joint view to make it more clear. If you would now move your character, then only the deformed bones and the parented bones would move along with it. The controllers for the head, for the pole targets of the leg, the eye key controllers of the leg wouldn't move together, so we need to fix that. I will go back to rigging mode. So what we would need is that these control bones move together with the corresponding rig element. That way when you export the animation, those control bones will also have the position and rotation baked into them. First let's take care of the root bones. Here we have a main root bone and also a hip root, as you can see in the outliner. We will set up a root constraint for these, and you can see it under the main action menu at the bottom. So what you need to do is select the root bone, and I will select this rigid body for the hip, and then add root constraint. And I will do the same with the hip bone. So I will select the hip root from the outliner and the rigid body of the hip and add a root constraint. You could also do the same with the root bone of the shape keys. So these shape keys would move together with the head. So maybe select this joint and the head and add a root constraint. And now if you search for constraint in the outliner, you have 3 different constraints. It's a good idea to name them here because you might not remember which one is which, so I will rename. We will need to get back to these controllers later, but now let's bind the control bones to the rigid bodies. So first I will do the head because it's the most straightforward. Here I will select the controller of the head, which is head DGT, and also the rigid body of the head. And instead of adding a root constraint, I will add this joint as an additional joint to this rigid body. So I will press connect under additional joint. And what you need to do is go over every controller and do the same things. And with the tail, I will connect each control bone to the neighboring rigid body. Now we saw that these joints move together with the armature because it's a child of the tail. So in case the bone is child of the deformation bone, then it will move together with the armatures, so we don't need to bind them. This is the same with these roll control bones which we saw in Blender, so you don't need to parent these kind of joints. But we will need to take care of the leg IK. And also the pole targets should be connected to the thigh, and if you have pole targets for the elbow, then those should be connected to the upper body. And now when you are done with all the control bones, I recommend you to export this rig as a JSON file because it can be handy to have a backup for this, so you can tweak it later. And now we can go ahead and generate the rig. And now if we move and rotate our character, it kind of follows well, but not quite what we would like. For example, the hip root only follows the character on the horizontal plane, as you can see. And also it would be nice to move the shape key targets vertically as well. So I will reset the pose. And now we will search again for the constraint objects. And here you can see different settings. So the shape key root constraint can follow the movement on the y-axis as well. The main root constraint can stay as it is because it's enough if it moves only on the horizontal axis. But for the hip root joint, I wanted to follow the pelvis on the y-axis as well. And also I will need to follow the rotation, because if we check the original rig, this is the hip root controller. It also controls the rotation of the pelvis, and also it moves on the x and y axis. But there are still some issues which you will probably also find with your rig. For example, if I rotate the head exactly 45 degrees, and when I export it to Blender, you can see it rotated 90 degrees. And if we go to pose mode, we can see that the head target is rotated exactly 45 degrees and the head controller is also rotated. So with this rig you can control the rotation of the head with both controllers, but we only need the rotation of one if we are using this method. One thing I could do, in joint mode I will select the head joint, and in the object properties under FBX export I will turn off exporting rotation, translation and scale data. I found that disabling only the rotation doesn't work in this case, but it should work if we disable all three. And now if I go back to Blender and import the action again, and now if we go back to Blender, we can see that the head rotation is correct and the second head controller is not rotated. And another drawback of this method is that you can see you have a lot of joints, exactly 228 in this case, although it's quite a simple rig. And this is over the limit of the free version. So when you try to export the animation like this, you will see an error that you exceeded the joint limitation, which is 120 joints. In this case, you can either modify your rig to go under the 120 joints, or you can consider upgrading to Cascadeur Pro. And if you choose so, you can use my link in the description and you can get 15% off your yearly subscription, and it's also the best way to support the channel. This method likely won't work with every type of control rigs. I expect generated rigify rigs might have an issue due to the incorrect hierarchy of the deformed bones, but we will go back to this topic in a future video. I know a lot of you wanted to use control rigs inside Cascadeur because then you have the option to modify the animation in Blender or any other 3D software. I hope this video can help you to achieve that. Have an amazing day.